Yeah, you take two 18 volt, you connect it in series, and you get 36 volts. You can only multiply volts. You can never multiply the amp with the batteries. Now, I prove it. I'm making way more in electricity and electromagnetic or electrostatic currents than what I'm putting in, because I'm putting in a very small source of energy and I'm multiplying and multiplying. Now, if you study Tesla's capability of amplifying energy is by 1,000,000 times. So far what I did there, I could have done another Lulu experiment there, and I can show you by using a full machine from you plug into the wall. I'm only getting so many volts. I put that machine, I plug into my Lulu unit, I'm doubling the output of the machine. Now for all the idiot out there, doing I'm making more than what I'm putting in, well, you know, you got to shake your head a little bit, because, you know, sometimes stuff gets stuck up there. This technology have to go to everybody around the world. That will disconnect your own energy system. Everybody can have their own energy. They don't have to buy energy. They can produce their own energy. Alright, so what we'll do is we'll find out how much energy a battery at 36 volt will give me, since this is a condensed bulb, 40 watt, 120, it's just a straight element. So we'll find out how much those batteries, how much heat. Everything is about heat. If you don't have heat, you have nothing. You can have lots of volt, but no heat will get you nothing. This is just a little switch, 2-speed switch, DC switch, on, off. So let's put that into maximum. So there again, here's my battery power, 36 volts, turning the bulb, barely no heat. So we'll change that and see if we can run a 7 watt instead of 40 watts. That's a little fluorescent. Not quite. Alright. Let's see if we can run this LED bulb, which costs about a fortune and a half. See? Very dim. But it runs it. So now we're going to do a change, and we're going to run the 36 volts into a regular 24 volt motor. It will spin that at very high speeds, about 4,000 RPM. And we'll see what comes out the other end. Now we'll reconnect that here. A lot of connecting and disconnecting in this show. So you have to kind of be patient a little bit. We'll go back to a 40 watt bulb. Lots of heat coming out of here. Okay. Let's go to a 60 watt bulb. It's a really big bulb, so it doesn't, the heat is pretty much controlled inside. But you want to pass me the big twisty over there? Thank you. Big twisty, that's a 40 watt twisty. It's about 12 years old since almost one of the first one came out. Let's see. Works just fine. Now let's see how much lumen. This is supposed to produce, what it says on it is 1065 lumen. That's a lot of lumen. Now, this is a lot of light compared to to those battery was illuminating that really low. Now we'll go back to the straight. Can you put that away since we don't need that? Thank you. And this one here. Thank you. I'll put back the 40 watt bulb, which is a stove or an oven bulb. Now I dare anybody, and I like you to do that, to take your lamp, peel up the insulation of your wire, turn it on like this, and then go like this with your finger across the two bare wire, and talk to me and see what is going to be the response. Because after maybe 30 seconds to a minute, someone's going to have to call 911. You will be dead. I can hold that all day long. Okay, because I'm not producing amperage. I'm producing electromagnetic watts. That means radiant watts. Good old-fashioned radiation. And that's what light up this bulb. It neutralizes itself, and I will show you. We'll go to voltage. I want to make sure you can see that. Okay. I'm going to pull the front out. I'm going to show you how much volt I'm pushing out right now. Can you read that? How much volt? Richard, can you read?
Yeah, 134.8.
134.8. I'm going to rebridge it. Okay. How many volts I'm putting out?
1.4, well, it keeps going down. 0.9, 0.8.
It's zero. It's
0.7.
It turns itself off automatically.
Yeah.
Because this current is smart. It won't let itself burn. And that's what this current can do. Now I'm going to show you something. We're going to pick up the voltage. When I'm coming out. 134 volts.
134 volts, correct.
Okay. Now watch that. Now I'm going to up it a little bit. We're going to use a small up transformer. We're going to crank this little puppy up to about 300 volt plus. Probably about 300 volt plus. We'll see. Okay. Again. Now I'm going to go to the how much I got there?
It keeps going up. It's right now. It's at 365.
365 volt. You don't want to touch that. It bites. It won't kill you, but it bites. Okay. Now I'm going to take a 30 watt fluorescent tube, which is burnt. I burn it so I can show you. I'm going to hook up one wire to that. Not two. See, those only work with two wire because there's an element on each end. This element is burnt. I burn it directly on the plug. I will hook up the other end. That's a UV bulb for a fish tank, which was burned. Doesn't look burned to me.
Nope.
Oh, because there's no gas in there, it's a vacuum. Lack of air makes the electron light up when it's on high voltage. Okay, that was a 30 watt. Let's try, I like those ones because they don't roll. Same here, I burn them up. One each side, and that's a 40 watt. Doesn't look burnt to me. As long as a vacuum, as long as no gas in there, I can ignite the electron flowing through. This generator it doesn't produce, it actually makes the electron manifest itself because I cannot make energy. Natural energy is not something you make or manufacture. You have to make it manifest. This is actually not a generator, but it becomes a modulator for the electron to flow. So now we will do something a little bit more sparky. Everybody think we have lots of juice, and high voltage can kill and destroy everything. This is a fully electronic ozone machine, an old one. I clean it up and fix it so it works. We are going to plug that behind you, that box right beside your foot there. That box, yeah, just right there, that's good. So I will turn this on. As you see, the light is on. I'm making ozone already, that's negative ozone. I should have that's maximum output. Right?
Yeah.
That's all I got of that machine plug out at that wall. Now bring me the line back. I'm going to put 300 and some volt in it. See, I'm plugging my little transformer. Come on, Chinese stuff. As you can see, can you see that properly in the video?
Yeah.
Okay. Now we'll turn this on. I will use, oh, here it is. I will turn it down because now it's going to be really sparking. I'm putting out more, and I'm not burning the electronic in this box. You can smell the ozone from here. Can you smell it, Richard?
Yeah.
Okay. And I test this box for days on, and it won't burn the electronic whatsoever. This power can run TV. You can take that off if you want to. You can run TV, you can run just about anything, and the nice thing about it is you will never burn a light bulb again. Doesn't matter if it's condensate bulb, fluorescent bulb, LED bulbs. Matter of fact, this little thing I tested on some LED, small LED light. If I would put 10 million little LED bulbs and cover my whole ceiling, this tiny little thing would light up the whole ceiling. You would not be able to stand here. That's what radiant watt is. But around the wire, I'm sending an oscillation into the battery. And remember, those batteries are very fragile. I burnt one already. If you discharge to zero, you cannot recharge this battery. They're garbage. You know, that's what lithium battery. They're very good, really hot, but they cannot go down. And I'm going to run an AC oscillation through the battery. It will take a few seconds here. It takes a while for the oscillation, for the battery to accept the oscillation first. You can't push anything because it's a computer, it's a multifunction chips in those batteries who runs equal amount of juice on all the stack of batteries. It's always mothering itself. If one needs a little bit, they will discharge from voltage into the other one. So we all good with that? AC, right? There we go. Now we're slowly going. It takes a while. It's not instant, but listen, that's technology people don't have, and here I have oscillating DC battery. This technology